The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to the Electronics Inside, the show where we tear down toys, tools and appliances just to find out what's inside. I'm David, and in this episode we're going to be tearing down a force feedback joystick. This particular model is a Wingman Force 3D force feedback joystick from Logitech. We have a throttle adjustment on the side. We have 2-axis plus what would normally be yoke or rudder controls. We've got 4 buttons on top. We've got trigger position, and we've got, I think it's called a top hat. This little sort of directional D-pad type dealio here, and 2 additional buttons on the base. Now that on its own would make it a pretty cool joystick, but this is a force feedback joystick. So you see it's kind of loose, and that's because it's got motors inside which hold it in position when you turn it on. And when you're actually, for example, using a flight sim, you'll actually feel feedback from the aircraft vibrating, shaking, forcing you back to center where you don't want to be. So we're going to take it apart, of course. It's kind of what we do. So this joystick in particular comes with a standalone power supply. Now this is a pretty old model. I think this is USB 1, possibly USB 2, which means it's limited to about 5 watts. We've got the switch mode power supply plug-in type, and this is 24 volts, 0.75 amps. So what's that, about 18 watts? So it's drawing more than you can get out of USB by some wide margin. Probably not using all of that all the time. Kind of expecting, well, the normal feedback to a joystick. We've seen this before in the 1970s vintage console teardown. That, you know, a joystick uses potentiometers normally to get positional feedback. Obviously there are other techniques. You could have optical encoders. You could have, what else have we seen? Things like the Xbox or the N64. I think they use different techniques. I think they were, the Xbox is a Hall effect sensor for its joysticks. Potentiometers seem to be the most common. We'll have a look what this is and see how that ties up with the motors. Okay. I have to admit, I'd kind of assumed that these little Allen bolts were decorative, but they seem to be holding on to something, so let's have them out. Okay, well that is a metal screw, but it is just turning. I'll just go around these and assume there's something backing off on the inside. Ugh. Oh, I hope that's factory grease. Ooh. This has got the potential to get really grim really quickly. 3. Yay! There we go. So that top cover's just got a couple of deformable pieces. There's nothing too much to see in here. Right, as with a lot of this stuff, I kind of take it apart and go, all right, I managed to get it apart by sort of contorting a screwdriver in there or something weird, but that can't be the right order of assembly. And it's only when you've taken the whole thing apart you kind of go, ah, that's what I should have done. Okay, so the throttle control is this potentiometer over here. See, there's a little arm linkage, so as that rotates around that, the inside of that blue collar, this little arm linkage just moves that potentiometer. Okay, at the risk of really nerding out here, is that giving you complete linear response? Because by taking the rotational movement of the tangent, putting it through lever linkage, it's going to move more at the center than it is at the extremities. So you see, as I rotate these, they're close in the middle, but on that same arc, they're further apart at the edges. So you kind of don't have that linear response for the high throttles or the low throttles. It's going to be more sensitive in the middle of the range. Then again, maybe I'm just overthinking this and it's something totally unnecessary for a joystick. See, I was just getting ready to criticize the big weights that are in here. I think there are other products on the market which I have heard, and I'm not going to jump on naming the bandwagon because one day we might do a teardown ourselves and discover what does and doesn't artificially weight their products so they feel more expensive. But in a joystick it actually kind of makes sense because you don't want your movements, especially when you've got force feedback going into this, really lifting up every time you try and make a movement, or it's snapping and jumping off the table every time it introduces some force. So on this product it actually kind of makes sense. Okay, just from its position on that axis, I'm gonna guess that that's the potentiometer that does the yaw control, and for whatever reason I had not expected it to be up here. I'd expected it to have been in the base. So the stick that sticks up in the middle is actually rigid and fixed, and it's actually the black plastic on the outside which then rotates around it. Okay, there's two of the top buttons. Not surprisingly, just a couple of basic tact switches under there. I'm expecting that to be the same. Still got this little top hat pad, which is kind of cool. I mean, I imagine it's probably actuated by some tact switches underneath. But it's got a nice mechanism with a really long screw that goes through to this sort of raised center point. So there is actually some spherical movement to it. It's not just rocking in position like a D-pad on a games console will. That's actually got some radius on it. So that washered screw over here is holding that in place. So this little plastic structure is what makes up the top hat, with that going all the way through it. And you know, there's some decent length on that. That's probably getting on for 20 mil. You know, in there, sat in the back of there, rocks about nicely. And yeah, the tactile switches that operate that mechanism are vertically mounted. Again, I hadn't quite expected that, but makes sense to use vertically mounted on the board and actuate them each way. Although quite a bit of backlash in there, but they are seated in here, so that wobble is only present since I've taken this apart. And of course the main trigger is a decent full-size micro switch, because I'm guessing in most sim games that's going to take most of the beating. And a tactile switch, it's not got the travel, it's not got the resilience, it's subjectively not got the feel to it. So micro switch makes sense. And yeah, that potentiometer for the yaw control for the rudder goes through this as a, well, I'd call it a daughter board. It's not, it's just a remote sensor. And yeah, that board's got a handful of passives on it, but nothing else otherwise. Okay, I have worked out what that spring did. So this spring sat slightly opened and pre-tensioned like that around this little shaft in here. How you install that, I've no idea. I guess actually it was the pre-tension around this nylon in the center which kind of helped you position that. But as you rotate that yaw, because that shaft is fixed, it's actually this spring providing the return to center for that yaw control. Whew. Worried I wasn't going to get that. And yeah, all that time I spent on trying to undo these Allen bolts, and they just go into little lock washers. Time well spent. And yeah, there is definitely grease on this. I mean, I'm very much hoping that is grease that was supplied in the factory with this deliberately, and it's not just gunk that has built up over its lifetime. Now, I consider myself not too squeamish, but yeah, there comes a stage when oh, look at it. It is everywhere, and so is all the dust and gunk. Let's just hope it's deliberate. Okay, first sight of the force feedback mechanism, and it's geared. So we do have what appear to be normal DC permanent magnet. I can feel the tweezers sticking to that. So they're decent torque, probably, motors, but they are actually being fed through gearboxes. So they aren't beefy enough on their own to provide the torque to give you good feedback. So that lead was the potentiometer of the throttle. This harness was plugged in there, and these two leads come over here to the potentiometers for feedback for the joystick. So you get a really nice view of the geared mechanism. Okay. So tiny little potentiometers, they are limited motion, but they don't actually even travel as much as they would allow. I mean, that's a 270-degree potentiometer, and it probably spent its life cycling the same 30 degrees every time. I hadn't made the association, but because the motor, or at least the feed for the axis, and the potentiometer are mounted perpendicular to each other, actually this motor is paired up with this potentiometer. So you see that this potentiometer is measuring this angle, whereas this motor is providing feedback in the other direction. So the X and Y components, so that's an X motor, that's an X potentiometer. This would have been the Y motor, and that would have been the Y potentiometer. I kind of would have thought that the two on the same assembly would have been the same, but they just aren't. You can actually see that this nylon injection molded part size, so you can feed this plug in and push it upwards. So each one of these two feedback motors is very similar, but they are completely distinct, and it's interesting choice in material as well. The fact they've gone for this clear, probably polycarbonate, and you've got a very small metal gear leading onto a large nylon gear, which again, you can see from sort of the colour of the grease on here that it's only used about 3/4 of its travel in its entire life. It's always got to that end. So I guess the next question is, how are they controlled? I mean, the last thing left in here is of course the control board, and there's not a lot on here. I'm pretty sure that's just a microcontroller. What have we here? That looks like a motor controller. Yeah, we're going to have to do a bit of looking up and find out exactly what's going on here. Okay, on board here you've got a dual output H bridge. Now that's just controlling the motors in both directions. You can see that it's obviously high power because it's got a lot of heat sinkings around it. Over here we've got what must be a custom part. I've spent ages looking this up and cannot find a datasheet for it. But this is directly connected to the USB header over here. And it also takes all the inputs from the analog side and digital. Now this little IC over here is just a voltage comparator, so this will be providing some demodulation from some of the multiplexed inputs down here over to this custom chip. Now if you have a way of finding out what this part is, please let me know. I'd love to get hold of a datasheet for it and actually find out a bit more. And you can see on the back that the 24 volts actually connects directly to this trace over here, which feeds into the motor controller. Everything else seems to be low voltage. It's only that motor output, which is 24 volts. And again, over here, there's the USB header coming straight over here, some of the inputs, and that input going over here to the voltage comparator. So that's probably demodulating some inputs back over here. The USB driving straight into that chip. She raises a good point because there's no clock on here. It must be using the clock from the USB. So there's no oscillator, no crystal. It must be using the external input of the sync from the USB speed. See, I think this joystick is just another example of how actually something really simple, a couple of DC motors, adds like a whole other dimension to a project, to a product. I mean, joysticks are kind of commonplace, and yet adding the force feedback's quite simple from an electronics control point of view, but it makes it something so much cooler. I don't know, maybe that's something that we could look at adding to our own projects. If you've got a project that's ongoing that you think this could inspire, why not let us know over at the Element 14 community? Head over to element14.com/the electronics inside. Thanks for watching. I'll see you next time.